For centuries, the greatest minds in history, from the courts of medieval Europe to the laboratory of Isaac Newton, shared a singular, obsessive dream: transmutation. They wanted to take a base metal, like lead, and turn it into gold. They saw lead as the bottom of the ladder, a dull, heavy, and dead material that just needed a little push to become something noble. But as our understanding of nuclear physics evolved, we realized that nature was doing the exact opposite. Gold isn't the finish line. In fact, lead isn't just a metal. It is the graveyard of the periodic table. Right now, billions of atoms of uranium, thorium, and radium are dying, decaying through time, with one specific destination in mind. Why does the universe seem so determined to turn its most powerful elements into a lump of gray metal? What exactly is magic about the number 82? Today, we go inside the nucleus to uncover why lead is the ultimate survivor of the cosmos and why everything turns to lead. To understand why things decay into lead, we have to understand the civil war happening inside every atom. In the center of the atom, you have protons and neutrons. Protons are positively charged, which means they want to push each other away with incredible force. The only thing keeping the nucleus from exploding is the strong nuclear force. Think of it like a cosmic glue that only works at extremely short distances. As atoms get bigger, adding more and more protons, the push of electromagnetism starts to win the war against the glue of the strong force. Once you pass the threshold of 82 protons, the nucleus becomes so crowded and so strained that it becomes unstable. It becomes radioactive. It is essentially a ticking time bomb, waiting to spit out pieces of itself to find a more comfortable, lower energy state. Nature is lazy. It always wants to be in the state that requires the least amount of energy. When a heavy element like uranium-238 or thorium-232 decides to decay, it doesn't just disappear. It goes through a decay chain. It might spit out an alpha particle, 2 protons and 2 neutrons, or a beta particle, turning a neutron into a proton. Each time it does this, it changes its identity. It becomes a new element. Uranium becomes thorium. Thorium becomes radium. Radium becomes radon. These elements are like runners in a relay race, passing the baton of instability down the line, but eventually they hit a wall. They hit an element that is so structurally sound that the decay simply stops. That wall is lead. Whether you start with the thorium series, the actinium series, or the uranium series, they all eventually reach their final, stable rest in an isotope of lead. So, why lead? Why not stop at gold, 79, or mercury, 80? In the 1940s, a brilliant physicist named Maria Goeppert-Mayer noticed something strange. Certain elements were far more stable than their neighbors on the periodic table. She proposed the nuclear shell model. Just as electrons orbit the nucleus in shells, protons and neutrons also sit in shells inside the nucleus. When a shell is perfectly full, the atom becomes incredibly stable: 2, 8, 20, 28, 50, 82, and 126. These full house numbers are called magic numbers. Lead has exactly 82 protons. This means its proton shells are completely full and locked tight. But it gets better. One specific isotope, lead-208, has 82 protons and 126 neutrons. Because both its protons and neutrons are at magic numbers, scientists call it doubly magic. It is the nuclear equivalent of a perfectly packed suitcase. It is so structurally perfect that no amount of internal pressure can force it to decay. It is the heaviest stable isotope in the known universe. For a long time, we thought the finish line was actually bismuth, 83. But in 2003, we discovered something shocking. Bismuth is actually radioactive. Its half-life is 20 quintillion years, over 1 billion times longer than the current age of the universe. This means that, in the extremely distant future, every piece of Pepto-Bismol in the world will eventually decay into lead. Even the elements we thought were stable are actually just on a very, very slow walk toward the lead graveyard. But is lead absolute end? Physicists are currently hunting for a higher magic. They believe that if we keep building heavier and heavier elements, we might find another magic number, perhaps 114 or 126 protons, where the shells become full again. This is called the island of stability. Somewhere in the deep future of science, we might create a super-heavy lead that lasts for millions of years. But for now, here on Earth, lead remains the cosmic dead end. Lead has a dark reputation. It poisoned the Romans, it's a toxic hazard in our paint, and it blocks the X-rays at your dentist's office. But in the grand story of the universe, lead is the hero. It is the element that finally brings peace to the chaotic, exploding energy of radiation. Thank you for watching What Exactly Is. Don't forget to like, subscribe, and stay curious. We'll see you in the next deep dive.